Now you'll learn about hash sets. A hash set is an unordered set that cannot contain duplicate elements, and it is a generic class. And in order to use it, we must import it. So import java.util.hashset or import java.util.star. And the following methods are commonly used with HashSet. First, size, which just returns the number of elements. Add, which adds an element. Contains, which returns whether an element of a given value is inside the set. And remove, which removes an element from the set. So for example, if we create a hash set of integer here, and then we add 5, 7, -3. And now if we print h.size, it should be 3 as shown below. And if we print h.contains 5, it should return true, but if I print h.contains 1, it should be false as shown below. And then if I do h.remove 5, and then I do all 3 of these again, it should turn out to be 2 because an element was removed, false, and false as shown below. And we can also directly print hash sets like this, and it'll show -3, 7 here. And also we can also loop through each element of the set. So for int I in h, if we just print I, it should print -3 and 7. Now if I add something like 1 and then I print the set again, you'll see that it outputs 1, -3, and 7. And in general, hash sets are not ordered. You can't expect them to order your elements in any way. They're just expected to store them. HashSet has no get method. There's only add, remove, and contains, basically. And its use comes in storing values and checking whether a value is in the set. Now, if I try adding a duplicate element, like if I try adding -3 and then I print it, then it'll still be 1, -3, and 7. And no matter how many times I add -3 to the set, it's still going to be 1, -3, and 7 because -3 is already in the set. So the hash set won't add the element again. Here's an example. Create a method that takes an array list of integer and returns a copy of that array list with no duplicates. So for this one, public static, the method must return an array list of integer, and let's call that method no duplicates. And it takes in an array list of integer. Then we'll need an array list to return. So let's call that result. And we'll use a hash set to remove the duplicates. And the way we'll do this is for every element of the list, if the element has not been seen before, then that means that we can add it to the result. So result.add I, add it to the scene, and then afterward we just return result, and then we're done. So then when we call this method, so first we need to create an array list. And then we call no duplicates on it, so array list of integer list2 equals no duplicates of list1, and then I print list1 and list2, and then it works. Now let's try the same problem except without HashSet. And let's comment out the HashSet one. So then, again, we need to store a result. And then for every element in the list, if result doesn't already contain it, so if not result.contains I, then result.add I, then return result. So at first this may appear to be better because it's slightly shorter and in code and it works just as fine. The problem occurs when my list is large. So let's just say I have a list and let's add the integers from 0 up to 499,999 into the list. And then afterward, let's call no duplicates on the thing. And then it takes a long time. And the reason it takes a long time is because this loop executes 500,000 iterations, and the contains method goes through every single element of the list until the element is found. So because this list has no duplicates, it just searches through every element. However, if I switch back to my HashSet version, then it runs almost instantly. And the reason is because HashSet takes a constant time to do everything, so HashSet is much quicker than ArrayList. While ArrayList contains method can take up to linear time searching through every element, the HashSet can take almost no time searching for an element because that's the way HashSet works. Let's say we have a class, let's call that rectangle. Let's give it a length and a width. And a constructor. And an area method, because why not? And now let's go back and create a hash set of rectangle. And let's add some rectangles to the set. And then let's also give the rectangle a toString method so that we can see what's going on when we print the hash set. And now let's print the set. And now you may notice that the set still contains two 5x7 rectangles, even though hash sets are supposed to remove duplicates. And now the reason for this is because Java doesn't know what a duplicate here is. We've never specified what a duplicate is. So Java treats everything as different unless they're literally the same object. So we need to be able to give Java the information of what makes two rectangles the same. Because HashSet checks the equals method, so we need an equals method. So public boolean equals another object. If O is null, return false. If O is not an instance of rectangle, return false. Rectangle R equals rectangle of O. Then afterward, return length equals R dot length and width equals R dot width. And now when I run the program, it still contains these duplicates, and that's because HashSet checks another thing, which is called the hash code. The hash code is a method inside object that by default returns something that's not very useful usually, something to do with the memory address, which is not what we want. So we want to override the hash code method in object inside our rectangle class to make it do what we want. A hash code must satisfy the following properties. One, most important, is that it must return the same hash code for the same objects. So objects with the same value must have the same hash code. So, for example, if I do something like return int of, say, math.random times 5, so random integer from 0 to 4, that's not going to be good. It's not even going to remove the duplicates because likely this 5x7 and that 5x7 rectangle have different hash codes, even though they have the same value, which is not good. Next property that it should satisfy is that objects with different values should try to have different hash codes. So basically, if we have two objects with different values, like two rectangles with different length or different width, it should be very unlikely for them to have the same hash code. So for example, if I do like return 0, which does satisfy the first property, but it doesn't satisfy the second property, that's not good. So first of all, it must satisfy the first property to even work. So if it satisfies the first property, it will definitely work, so it removes the 5x7 duplicate. However, it's not good enough because it has like everything has the same hash code. And the thing is, HashSet stores everything by hash code. So if everything has the same hash code, everything's stored in the same place. And the problem occurs when I make a large hash set. So for example, I add 50,000 elements to the set. So rect set dot add new rectangle I comma I, let's just say. And now all of a sudden it takes forever to add the new rectangles. And the reason is because, well, everything's stored in one place, so it's hard to check whether a rectangle is already inside the set or not. So then 0 is clearly a bad hash code. A slightly better hash code would be just like the int value of length, for example. And that would work in this case, but let's just say I have a bunch of, say, 1 by I rectangles. Everything has the same length. Then all of a sudden, it takes forever again because, again, all of these rectangles have the same hash code, which is not good. A slightly better hash code than that would be something like return int value of area, but that's still not good. So it works in these two cases, but let's just say we have 0 by I rectangles because why not? And then it's going to take forever again because all these rectangles have the same area, and that's not good. So then, how should we do this? Well, let's take a look at the length and the width separately. So length is a double. So let's use double hash code. So int hash length equals new double of length dot hash code. What's the benefit of this? Well, double hash code we can assume is pretty good. So basically different lengths would yield a different length hash most of the time, which is good. We can assume that double has a very good hash code because it's an essential part of Java's library. So Java would give it a good hash code. Then same thing for the width hash. Then when we just put these together, let's just return, say, a large prime number times length hash plus width hash, and it should be good. So now it runs almost instantly. And this thing can be a not prime number, but it's just a prime number just to reduce collision a little bit more. And now it works. Now let's see what happens to this code when we don't have our equals method. So let's just comment out this equals method right here and see what happens. Now all of a sudden, before we add the 50,000 elements, we still have duplicates, this 5x7 rectangle and that 5x7 rectangle, because HashSet checks the equals method as well for determining duplicates. The reason it checks both the hashcode method and the equals method is because if two elements have an equal hashcode, but they are different, then HashSet doesn't want to not put both of them in the HashSet and treat them as duplicates when they're really not. So therefore, just for safety, HashSet checks both the equals method and the hashcode method. So we should implement both of these methods properly before we create hash sets of our own class like rectangle.